All right, welcome to Finding Holes in Graphs of Rational Equations. Many of you requested more help with finding those holes, so let's work just on that. I've set up some example problems that we'll look at now. All right, here's my first example problem, and it's not factored for you yet, so let's start with the factoring. I can factor an x out of the numerator, and that's going to leave me x plus 1. The most obvious thing to start factoring out of this denominator is negative 2. So we'll factor out a negative 2. That leaves me with x squared minus 1. And that is a difference of squares, so we're going to have to go on and factor it again. I have x plus 1, negative 2, x plus 1, x minus 1. And that means that I do indeed have a hole in this graph. I have a hole in this graph because I have a factor that is common to the denominator and the numerator. So I know that my disallowed value of x here is negative 1. That's where my hole is going to be. But I also have some other disallowed values. Let's just get that back on there. So if I want to find out where my hole is on the graph, then I'm going to need to find out what the value would be if I just divided out this version of 1 here and graphed the function x over negative 2x minus 1. That is the function I'm going to use to find the y value for this hole. So if I put in negative 1 for x here, I'm going to get, this will be my g of x. So g of negative 1 is negative 1 in for my x over negative 2 times negative 1 minus 1, which is negative 1 over negative 2 times negative 1 minus 1 is negative 2. Negative 2 times negative 2 is 4. So my hole is going to be at negative 1, negative 1/4. So here we go, negative 1, negative 1/4. I can't be too accurate, but there's my hole on the graph. All right, so we also know that we are going to have a vertical asymptote at x equals 1, because that would be a 0 that is not removable from the graph. Remember that our holes could be removed by defining the value of x at negative 1 as negative 1/4. So our unremovable division by 0 here creates our vertical asymptote. We have powers of x that are the same, so our horizontal asymptote is going to be at negative 1/2. There's a 1 there. So that's going to be below our hole here. And when we sketch in our graph, it's going to approach this asymptote, come through here, and approach this asymptote infinitely from here, and then it's just going to exist also on this side. And you can grab some more points or check some points to verify that that is indeed the way our graph is going to look. Let's find the holes in another graph. Once again, we have to start by factoring. And I can factor an x out of the numerator, and that gives me x times x plus 3. And in the denominator, two things that add to 7 and multiply to 12, all positive, x plus 3 times x plus 4. So once again, I have a factor that is common to both the numerator and the denominator. So I'm going to have a hole where x plus 3 would equal 0, or at x equals negative 3. So in order to plot the hole on the graph, I'm going to need to find the y value. It's also, I think, a little bit easier if I sketch in some asymptotes. So my vertical asymptote is going to be where x plus 4 equals 0, or at negative 4. So let me just sketch that in quickly. And my horizontal asymptote, since these are the same, is going to be at the ratio of the coefficients, which is 1. Now let me find the y value of this. I'm going to look at the equation that I have left if I take out this factor of 1. So I'm looking at x over x plus 4 for my g of x, in which I've removed the hole so that I can find the y value where x equals negative 3. I plug in that negative 3 for x. I have negative 3 over negative 3 plus 4, and that is equal to negative 3 over 1, or negative 3. So negative 3, negative 3, negative 3, negative 3, there's my hole. And then we can find some more points. We should find our x-intercept, which is going to happen at 0, because again we're going to ignore our x plus 3 and set this, or I should say this, equal to 0 is going to happen where x is 0. So here's our x-intercept, and I'm going to finish sketching off my graph here, not through the hole, but towards my asymptote, and it's going to be similarly over in this quadrant, or this section off of my asymptotes. And there you have it, finding your holes and sketching.